Welcome back. Mr. Sutton bringing you one more lesson on similarity. In this one, we'll take a look at the Sidesplitter theorem, where we use proportions on triangles with parallel sides to find some of their measures, and also proportions on triangles that have angle bisectors. Let's talk about the Sidesplitter theorem. If you have a line that is parallel to the base of a triangle, the Sidesplitter theorem says that that parallel line divides the triangle sides proportionally. So, for example, in this picture, we could say that A to B is the same ratio as C to D. And we could also, if we just kind of cross-switch these things, say that A over C equals B over D. So what does this mean in terms of solving triangle problems with that parallel side in there? What it means is that you can set up a proportion with the numbers exactly the way they appear in the problem, at least in the picture. So we can say x over 9 equals 4 over 6. It's really quite remarkable. It's almost like this parallel line is just a big fraction bar setting up our proportion for us. And then cross multiplying, we have 6x equals 36, so x equals 6. Here's another problem with a parallel side in here. Let's pause the video and see if you can find the length of YZ. All right, let's see how you did. So I just put a letter in there, x, to represent that, so I don't have to write out that bulky YZ expression. I'm going to set this up exactly the way it looks here. I'm going to say 35 over x equals 45 over 36. And then cross multiplying, I'm going to get out my calculator actually. So I've got 35 times 36, which comes out to 1260. 45x equals that, so I have to divide 1260 by 45. And let's just go back and divide here by 45, giving me 28. So the Sidesplitter theorem is pretty useful for finding missing sides if you already have parallel sides here. But what if you want to figure out if the sides are parallel to begin with? Well, the converse of the Sidesplitter theorem says that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So, does this line divide the triangle proportionally? Let's find out. 90 over 72, is that the same as 50 over 40? Well, 90 and 72 are both reducible by 18. That gives us 5 over 4. 50 over 40 is also 5 over 4. Since these sides are proportional, we can say yes, PS is parallel to QR. Now, some of you might be wondering, what if we have the parallel sides, but we don't actually have a triangle? Like in this situation here, where we have 3 parallel lines with these transversals. Well, the Sidesplitter extension says that if 3 parallel lines divide transversals, it's proportionally. So we can set up another ratio with these. Pause the video and set up the ratio the way you think it should be done, and then find the value of DE and EF. All right. So the easiest way to set this up is just the way it looks spatially. 4 over 3 equals 4x minus 8 over x. Cross multiplying, we've got 4x equals 12x minus 24. Careful to distribute there. So we can subtract the 12x. That'll be negative 8x on the left. Dividing by negative 8, we have x equals 3. Now EF is exactly whatever x equals, so we know that EF is exactly 3. DE is going to be 4 times 3 minus 8. 12 minus 8 gives us 4. Well, that's kind of funny. This is 4, just like this, and this is 3, just like this. Doesn't have to work out that way, but it did in this case. We're going to switch gears a little bit to take a look at something called the angle bisector theorem. So an angle bisector is basically just a segment that cuts an angle in half, like this BC segment that cuts angle B in half here. So if you have one of these situations in a triangle, then the angle bisector divides the opposite side of the triangle into segments that are proportional to the adjacent sides. In other words, we can just set it up like Sidesplitter style. 10 over x equals 15 over whatever this side is. The problem here is that they didn't give us this CD side, so we have to do a little bit of creative algebra. We already know that the whole side AD is 20, and we've lost x of it over here. So to get CD, we have to do the whole side 20 minus x. All right, now we can set up our proportion. 10 over x equals 15 over 20 minus x. So cross multiplying, 15x equals 200 minus 10x. Adding 10x over here, 200 divided by 25 is going to be 8. For the wrap-up on this one, you might think, wait a sec, Mr. Sutton prematurely displayed some animations, and no, I'm asking you what is wrong with the solution I've displayed below. So pause the video, check out this situation, and see if you can find the problem. Did you spot it yet? So we said 14 over 6 equals x over 9, and cross-multiplied, and x does indeed equal 21. But what were we assuming here? Did they ever tell us that this line was parallel to this one? No, they did not. If you don't have parallel lines, you can't use the Sidesplitter theorem. So that's it for Sidesplitter and friends. Until next time, this is Mr. Sutton signing off.